All right, we're starting to talk about probability. And we're going to have a couple of terms, but this is not going to be as vocab heavy as the last chapter. So one of the main things that we're going to start talking about here is a probability model, which describes each outcome and the chances of it happening. So usually it looks like a table. So if we make a table here, this table is going to have two rows in it. It's going to have whatever the outcomes are, the potential possibilities are, and then the probability of it happening down in the bottom row. So if we flip two coins, there are four different outcomes that we could get. We could get two heads. We could get the first flip being heads and the second flip being tails. We get the first flip being tails and the second flip being heads. Or we could get both tails. And each of these are equally likely to happen. Each of these four have the same chance of happening, so they each have a probability of 0.25, or 1/4. So this is what a probability model looks like. You have the outcomes listed at the top, and you have the probability of each thing happening listed at the bottom. Here's another example. If I roll two dice, let's say one die is red and the other is green, then here are all the possibilities we can have. I have a red die being a 1 and the green die being a 1. I have the red die being 1 and green die being a 2, and so on. There are 36 total different ways we could roll the dice, because there are 6 outcomes for the first and 6 outcomes for the second. So 6 times 6 is 36. And each of these rolls are equally likely to happen, so each roll has a 1 in 36 chance of happening. Now, let's say that we want to figure out the probability of rolling the two dice and having the sum be 5. So let's say we want the probability of rolling a 5. Well, we could just count up all the different ways I could get a 5. And we could take that out of the total number of different ways that the dice could roll. So in other words, here are all the ways that we could get a 5 out of how many different possibilities there are. And that's the general way that probability is going to get calculated. What are all the ways that the event could happen? So the event in this case would be rolling a 5. And out of how many different possibilities for the thing happening are there? So we say that there are 4 different ways out of 36. So 4 out of 36, or 1/9. Now, let's say that we have an event that has the sum not being 5. So the probability of the sum not being 5, well, we could list out all the different ways we could get anything other than 5 and count them all up, and we'd find that there's 32 of them. But an easier way to do this is to say, well, if I want all the times that are not 5, let's collect all these times where it is 5 and then toss them out. And what we're left with is all the times that the sum is not 5. So we decided there were 4 times that the sum is 5, so let's throw those out. We're left with 32 of them out of 36. So this idea of taking everything except what we're interested in is going to be useful for calculating probabilities, because sometimes it's going to be easier that way. So combining these all together are going to get the basic rules of probability. So the probability of an event is anywhere between 0 and 1. And all the possible outcomes together have to have probabilities that add up to 1. In other words, the probability of everything that's possible to happen is going to be 1. 0 is going to mean that the event is impossible to happen. So if I roll those dice and get a 15, well, that's not going to happen, because the largest I could get is 12. That has a probability of 0. And then we can have certain probabilities that have a probability of 1, which is what every single possibility you could have should end up being 1. And then this is what we talked about earlier, total number of outcomes out of everything that's possible. So total amount that we're interested in out of the total amount that is possible is how most probabilities get calculated. And then the probability that an event does not occur is 1 minus the probability that the event does occur. And if you remember when we talked about set notation, this was called a complement. And we put a little c at the top of it to say that we're talking about the complement. And we can do that by taking 1 minus the probability that it does occur. Or we can do it the other way. So sometimes if you're asking what's the chance of something happening, it might be easier to ask what the chance is of it not happening. So we'll start to look at those as we go along here. And then if the two events have no outcomes in common, the probability that one or the other occurs is just the sum of their individual probabilities. So if we're totaling up the different outcomes and possibilities that can happen, if we're trying to track two different outcomes at once, as long as they can't happen at the same time, then we can just take those different outcomes and add them together. If there's some overlap, then we need to take that into account. And that idea of there not being overlap is called mutually exclusive. So two events are mutually exclusive if they have no outcomes in common and can never occur together. And so if you remember us talking about Venn diagrams, the Venn diagram of two things being mutually exclusive would look like this. We'd have a circle, no overlap between them. So in our dice example, we could say rolling an 8 or rolling a 9. Because those two things can't happen at the same time. I can't have the roll come out to be both an 8 and a 9. So if I want the probability of getting an 8 or a 9, I just take all the times that I roll an 8, all the times I could roll a 9, and add them together. And that would be my probability. So these basic ideas of probability are ones that we're going to look at today. So here they are stated in a more technical way. Probabilities are between 0 and 1. Probability of every event happening together is 1. Here's my complement. Probability of something not happening is 1 minus the probability of it happening. And then my addition rule for mutually exclusive events. In other words, if I have two events that can never happen together, and I want to tally up the chances of one or the other happening, I can just add them. So we're going to look at a couple of examples here. First example. Our first example here is that we have a probability model. So we've got our age groups and then the probability that they're in that age group. So the first question we have is this a legitimate probability model? Well, the main rules that we have to look at are the first two, which is that every probability should be between 0 and 1. Check. That's there. But we should also make sure that our probabilities add up to 1. So if we want our probabilities to add up to 1, then let's double check those probabilities. 0.57 plus 0.17 plus 0.14 plus 0.12. And if we add those together, we should get 1, and we do. Then we can say the probability that we are not 18 to 23. Well, there's two different ways we can do that. The easiest way is to say if we're interested in not being 18 to 23, then our rule for complement says that that is 1 minus the probability that they are 18 to 23. Which is 1 minus, the probability of 18 to 23 is going to be 0.57. And so that's going to end up being 0.43. The other way we can do this is that if we want to add up the places where they're not 18 to 23, let's see. This is not 18 to 23. This is not 18 to 23. This is not 18 to 23. And notice all these are mutually exclusive. You can't have somebody that is both in the 24 to 29 age bracket and be 40 and over. They can't happen at the same time. So if we want to take the probability of all these put together, then we're going to add them. 0.17 plus 0.14 plus 0.12. In other words, if they're not 18 to 23, then they're either 24 to 29, 30 to 39, or 40 or over. And the common rule that you're going to see as we go forward in these probability rules is that or probabilities you're going to end up adding. So if you're listing out the probabilities and the potential ways that something can happen, and you find yourself saying or, either this can happen or this can happen or this can happen, then you're going to end up adding together those probabilities. In our next example, we're going to make the probability model. So I'll show scoring the 1, and then I'll fill in the rest. The probability of 1, well, let's take everybody that scored a 1, 52,205. And let's take that out of everybody who took the test. So out of 222,863. If I divide that out, I get 0.23. So before I go on here, I want you to try and get the rest of the probabilities. You're going to take the number in that window and then take it out of the total number of people who took the test. So what proportion got a 2, what proportion got a 3, got a 4, got a 5. Here they are rounded to the nearest hundredth. And notice that these probabilities, if I add all these together, I end up getting 1. If I add all these together, I get 1. That's what you should end up with. Now, if you're rounding these numbers, then it might be a little bit off. So you might get like 1.01 or 1.02 or 0.99. If you do that, no big deal. If you're getting... then that might just be a rounding thing. If you're getting like 1.5 or 0.7, that's when you know something's off. These should add up to 1 or 1 with a little bit of a rounding error. But next one, probability that students scored at least a 3. So the probability that X is at least 3. See if you can think up this answer before I give it. Well, at least 3 would be, how could they score at least a 3? Well, they could score a 3, or they could score a 4, or they could score a 5. These are the different ways that they could score at least a 3. So we have 0.25, we have 0.21, and we have 0.15. And since these are OR events, then we're going to add them. A 3 or a 4 or a 5. So that's going to end up being 0.61. Now the other way you can do this, is to say that this is the same as 1 minus the probability that they don't score at least a 3. In other words, that they score less than 3. Well, how could they score less than 3? Well, they could score a 2. They could score a 1. So 0.16 and 0.23, that is 0.39. Those are the different ways they could score less than a 3. So 1 minus 0.39, that's going to be 0.61. Next one I want to have you try on your own. And so we asked, is this a valid assignment of probabilities? I'll at least get you started to say that this is not, because here's 0.5, here's 0.3, here's 0.1, and if I add them together, I get 0.9, which is not 1. So these don't add to 1. So what we do in the next bit of the notes is that we add in an other category so that it adds to 1, and you're going to make a probability table and find some other probabilities. So that's all for now. Next time we're going to finish up this section of notes. We're going to talk more about when things aren't mutually exclusive, when we have some overlap between two things. How can we avoid that overlap and double counting? So we'll do that soon, and I'll talk to you guys then.